Have you ever wondered about the pencil you've used since childhood, the one that guided you to where you are today? It's made of wood, but how is the black lead inserted inside? Or consider the airbags in cars, which save thousands of lives daily. How do they inflate so quickly during an accident? And most importantly, when and why was the very first airbag in history created?
Hello and welcome. If you're new here, welcome to Amazing 5.
In our daily lives, we use many things without knowing the hard work and techniques that go into making them. So, let's explore the manufacturing process of 5 such products that we use almost every day. The first idea for an airbag came to an industrial engineer in 1952 after he and his family were in a car accident. Everyone survived, but the incident sparked the idea for a safety device. 2 years later, he developed an airbag that used a compressed air cylinder to inflate. The problem was that this process was too slow, and in an accident, every millisecond counts. For many years, there was no solution to this problem. Then, in 1967, an American engineer came up with a new idea. He decided to inflate the airbag with gas produced by a chemical explosion. Inside the airbag is a chemical called sodium azide. When a car's crash sensor detects an accident, it sends an electrical signal to the chemical, causing an explosion. This releases nitrogen gas, which instantly inflates the airbag. The entire process, from the crash to the airbag's full inflation, takes only 20 milliseconds. That's 5 times faster than the blink of an eye. The material of the airbag is also special, woven from 1,000 nylon threads at once to create a single durable piece. If even one thread breaks during this process, a sensor immediately stops the machine. Despite its speed, the machine can only produce 8 meters of fabric per hour. Once the fabric is made, it's washed, dried over hot rollers, and pressed. To make it airtight, a silicone coating is applied using computerized rollers, and then the fabric is dried in large ovens. Finally, the material is cut into different shapes and sizes by a computer-operated machine, sewn and tested for quality. Now, let's talk about aluminum foil. It's so thin that even a little pressure can tear it. But have you ever thought about how heavy blocks of aluminum are transformed into such a delicate sheet? First, pure aluminum ingots, small pieces of the metal, are melted in a furnace. It takes 8 hours to melt 27,000 kilograms of aluminum. The liquid metal is then filtered to remove impurities and poured into a die to cool and form large blocks. Each block weighs around 7.5 tons and is lifted by a crane onto a milling machine with hot rollers that gradually press the block thinner and thinner. After just 15 passes, a 45 centimeter thick block is pressed down to 5 centimeters. This sheet is then moved to another milling machine to be made as thin as foil. The edges get damaged in the process, so a cutter blade trims them. On the other side of the machine, the finished aluminum foil is wound into rolls, ready for use. Next, let's uncover the secrets of bulletproof glass. A 9mm bullet is powerful enough to pierce a thick steel plate, so how does it fail to penetrate bulletproof glass? The process begins with a normal sheet of glass, which is bent in an oven because curved glass is stronger than flat glass. 4 of these bent glass sheets are then layered together with a sheet of polyvinyl butyrol, PVB, in between each. This special sheet not only holds the glass layers together, but also adds to their strength. The sides of this sandwich are taped, and the whole thing is wrapped in a plastic sheet, which is made airtight. A vacuum pump removes all the air from the plastic wrap, and the glass is placed in a large container. The air pressure inside is 10 times that of our atmosphere, and the temperature is raised to 278 degrees Celsius. This heat and pressure fuse the glass and PVB sheets into a single solid unit. When a 9mm bullet hits this glass, the outer layers absorb and distribute the energy, while the middle PVB sheets stop the bullet, preventing it from reaching the final layer. Finally, let's look at pencils, often called lead pencils, though they don't contain any lead. The core is actually graphite, which leaves a black mark on paper. The first pencil was made in 1630. Because graphite and lead look similar, People mistakenly thought pencils contained lead. This confusion was cleared up in 1789, but the name lead pencil stuck. The manufacturing process starts with a mixture of graphite and clay. While the clay is still soft, it's pressed through small holes to form leads of a uniform size. These leads are then dried in an oven to harden. For color pencils, the same process is used, but with clay and color pigments instead of graphite. The leads are then placed into grooves carved into 10 mm wooden sheets, glued, and another sheet is placed on top. This sandwich is then dried in a large wheel to ensure the leads and wood are securely bonded. After drying, a milling machine cuts the sandwich into individual pencils of various shapes. The pencils are then colored, stamped, and put through a stress test to ensure the leads can withstand over 2.5 kilograms of pressure. Finally, they are sharpened and packaged. And there you have it, the incredible journeys of everyday items, from raw materials to the finished products we use without a second thought. Use arrow up and arrow down to select a turn, enter to jump to it, and escape to return to the chat. Start typing a prompt